Hello everyone, so my name is Nolwenn Hurel. I'm working at Cerema and I will present the ventilation information paper, Building Airtightness Impact on Energy Performance Calculations. Okay, so with Valerie, we published this ventilation information paper with the AIVC. This was published in September 2023. And this publication is available on the AIVC website, so you can all access it for free. I will first give some introduction on this subject. So first of all, about the energy performance of a building. So this is the total annual energy consumption of the building that includes heating, cooling, and also ventilation. In some countries, it is calculated before the construction of the building to check the conformity with the requirements. And in Europe, we have the EPBD, which is the European Energy Performance of Buildings Directive, which was introduced in 2002, revised in 2018, and very recently this year. It obliges all the countries to have a national building energy performance calculation methodology. And about building airtightness regulation, we have over the world more and more countries that have mandatory envelope airtightness requirements. Some of them have mandatory justification, some not. There are various indicators that are used depending on the countries. It can be volumic, surfacic, a different type of pressure, and also various criteria to determine the threshold values. The ventilation systems in Germany, the type of dwellings in France, the compactness of the building in Spain, the climate zone in the US, etc. And some countries do not have requirements, but they have recommendations. You have a map here that is from another publication we made with Valérie. That is an overview of the airtightness ventilation information papers we published in 16 countries. And you can see the 16 countries. In red, it is the countries where there is no mandatory requirements on airtightness. And in green, the countries that have a mandatory requirement, at least for some type of buildings. The light green, that do not have a mandatory justification. And then you have France, Norway, and in the US, where there is, at least in some cases, the mandatory requirements and the mandatory justification. So this is one way to really improve airtightness in one country. And another, or a complementary option, is to encourage airtightness, is to include the air infiltration in the energy performance calculation of the building. So for this, the energy loss due to infiltration is calculated based on the envelope air leakage rate. This is what we need to have this airtightness that is included in the EP calculation. And then a poor airtightness can jeopardize the possibility to comply with the global energy performance requirements. So this is how it encourages also a good airtightness. So as I said, we need to calculate the infiltration rate to have it inside the energy performance calculation. If we want to have a real accurate calculation of this infiltration rate, we need the precise pressure distribution across the envelope that depends on the wind, on the mechanical ventilation, and on the temperature difference. And we also need a precise leakage distribution and characterization of each leak, so the flow coefficient C and the flow exponent N. So in theory, we should sum up all the leakage of all leak and to have the total infiltration. But in practice, this is quite impossible. We don't have a precise idea of the pressure distribution of a random building. And also, we don't know the leakage distribution and the precise characterization of each leak. So usually what we know is a global estimation or measurement of the whole building envelope. And we usually have that at 50 Pascal, whereas the operational pressure difference is rather between -10 and 10 Pascal. So for all these reasons, there is a need of simplified models to include this infiltration rate inside energy performance calculations. So about these simplified models, there are different ones. Basically, almost each country has his own simplified models, but I will give the different kinds of models, and you will see they have different levels of complexity and different levels of accuracy. So first, you should know that some countries do not include the airtightness, the envelope airtightness in the EP calculation. This is the case in Switzerland, also in Sweden, where they do have requirements on envelope airtightness for new buildings, but the energy performance certificates are based on measured energy performance, so they are not anticipated with calculations. And in New Zealand also, they have no specific target for building airtightness, and they have 3 methods to comply with the performance requirements, and only one of them includes airtightness as a constant. But it is really not the preferred choice, as it is the most complex one to implement. Now, for the country that do include infiltration and airtightness in the energy performance calculations, the most simple model is the leakage infiltration ratio. So it is a linear relationship between the infiltration rate, so it is the estimation of the real infiltration through the year, and the leakage rate at 50 Pascal, which is what is usually estimated or measured on site. So it is used to estimate the building steady state infiltration heat loss, usually applied in semi-steady state calculation methods. And it gives a quick estimation, but with significant limitations, as it is very hard to define the proper N coefficient. One country that uses this model is Belgium. So Belgium is an interesting country for airtightness because they do not have a requirement on minimum airtightness level, but they have a very disadvantageous default value in the energy performance calculations for airtightness if there is no test performed. So as a result, in Flanders, they have a requirement on the global energy performance that the building must achieve. And because of this very disadvantageous default value on airtightness, all buildings are actually tested to have a better value and to be able to comply with the energy performance calculations. And the coefficient they use in Belgium is 25. But of course, it will be more or less correct depending on the buildings. In Finland, this coefficient depends on the number of floors, ranging from 35 to 15, 35 for one floor to 15 if there are more than 5 floors. And now there are other models that are more complex. We call them the simple infiltration models. So they take into account more parameters, usually time-dependent ones. They are more complex, but also more accurate than the leakage infiltration ratio models. And one example is what is done in the UK. So the coefficient used is 20, but there is a monthly correction factors to account for wind fluctuations. And I won't say more than that because Xiaofeng will present right after me in details what is done in the UK. And also in the US. So it's hard to talk about the whole country as the situation is different in each state. But most states have adopted the International Energy Conservation Code with limits for leakage and 3 compliance methods, including the Energy Rating Index, that is the hourly air exchange rate for the year that is calculated and that includes the stack and the wind coefficients. In Spain, they have requirements on airtightness since 2019 for residential buildings that are bigger than 120 square meters. And then for the EP calculations, they have a dynamic hourly model, but the infiltration is calculated with a simplified model with various parameters. So 2 values of wind speed, given pressure coefficients, exposure to wind, flow coefficients, and ventilation design rate. And finally, the most complex model that is used is the equilibrium pressure model. So in this model, the pressure is calculated by a mass balance equation. So it's more complex, but more precise than the 2 other models presented, the leakage infiltration rate and the simplified infiltration model. The calculation is performed at a time step, often hourly. And it requires an estimation of the pressure and the leakage distribution. Valérie will present this type of model after the presentation of the UK. And Jerry will present what is done in Czech Republic. So they use this kind of model. And it is also used in France in a very similar way to how it is done in the Czech Republic. So, as I said through the presentation, the various models have different levels of complexity, but also of accuracy. And there is one study that has been done by Happel and al. To try to estimate the error due to the use of these different models. So they made a test on 24 Swiss buildings. And they compared 2 models, one simplified infiltration model it's from Germany, and one equilibrium pressure model. And they found out very significant differences. So the graph you see here, it's the difference in the annual heating energy demand. So it's the total energy performance of the building. And you can see that the model choice can drastically affect this whole energy demand in the individual building level. So they found out that the annual heating demand was reduced with the equilibrium pressure model for all buildings but one, with an average reduction of 11.6%, which is, I found, very significant, and a maximum reduction of 65%. So you have here a table as a summary of what I presented. So each country has a different approach on airtightness. Some have requirements directly on new buildings, the requirements on the airtightness they should have. And others, they don't have these requirements, but thanks to the implementation of airtightness in the EP calculation, they can encourage a good airtightness. And as I presented, each country has a different way to introduce the airtightness in this calculation with models of different complexity and different accuracy. And to finish, I also added this table to the presentation that is also from the other publication we made with Valérie, that is summarizing the trends in buildings and network airtightness in 16 countries. And here you have other countries I didn't mention during this presentation. So, for example, Greece, they have airtightness in the EP calculation, but with tabulated values depending on the type of windows and doors. You have also Germany that I mentioned with the comparison. So they have a simplified model depending if there is a ventilation system or not. Estonia, that is very similar to Finland. Also Korea, that has also a simplified infiltration model with a shielding factor. And I think that's all. Norway also, that has a coefficient that depends on the number of facade exposed and the degrees of exposure to wind. That's all for me. If you want to have more information on this subject, please don't hesitate to check the paper that is available on the AIVC website. And I thank you for your attention. If you have any question, please don't hesitate to ask.